I'm Randima Fernando, one of the co-founders of Center for Humane Technology. There are many, many hours of content we could share today with you about AI. So I've tried to focus on what we think will be of most service to you, including principles, trends, themes, and from nearly 2,000 questions that you all sent in. And I also want to address some of the common myths and misconceptions along the way. You all represent a very wide range of backgrounds, so not everything that I cover will apply to everyone. But I promise we'll have plenty of helpful material for anyone. Okay. So what we'll cover today are capabilities of general purpose artificial intelligence, some backgrounds on how large language models work. So these are LLMs, where things are going wrong, AI and the economy, deepening disparity, and paths forward. So first of all, in case you haven't seen it yet, please watch The AI Dilemma by Tristan Harris and Isa Raskin if you haven't already. That talk covers a lot of interesting material, and this talk builds on that and assumes that you've already watched that. So what are we talking about today? We're talking about general purpose AI. So that is AI with generative capability. So text, images, audio, video, etc. The ability to reason and other enhancements. And we'll also talk about hallucinations and how that is still a problem. First, a quick recap of generative AI. So this is an image from Midjourney 5. It looks great, of course. And this is kind of where the state of the art is. And we're very good at generating these. You can see the massive improvement, right? So V1 here is from February 2022, and V5 is from February 2023. And there's a massive improvement in performance in that time. And you can see, you can learn a lot more about this. There's a great channel on YouTube called AI Explained that covers a lot of this material. And this example comes from there. It's fantastic. We can also reproduce voices really well. We can make songs, right? And we can reproduce voices with just 3 seconds of audio. And if we have more samples, we can do even better. We've had massive jumps in performance on exams and these kinds of tests. And actually a lot more has happened even since March 2023 when GPT-4 and these kinds of results were released. And you can see the jump, right, in from GPT 3.5 to 4 on the bar exam went from 10th percentile to 90th. And on GRE quantitative went from 25th percentile to 80th. So there's a lot of capacity in there. And the other thing is there have been an incredible number of plugins released recently. So the key point here is these technologies can now interface with all of your favorite apps, and it's kind of supercharging the economy. We'll talk a lot more about that and kind of the risks there. And it includes apps like Zapier, which is actually integrated into 5,000 apps. So through that, you can control like a vast space of possibilities. And of course, that also opens up a vast space of harms. Next, I'm going to go through a few examples related to reasoning and general purpose AI, because this is an area that's often misunderstood or sort of underestimated. And it's an interesting moment where there is a ton of low-hanging fruit. So researchers are publishing like crazy with consequential new papers coming out every few days. So here's one example, right? When you give an input, like a prompt or a request, the model actually runs through a whole tree of possibilities, explores different paths before it answers. And it kind of scores those paths and says, oh, like this path with the dark green boxes, that one scored really well. So that's the one I'm going to use. And that automatically makes the model a lot smarter. Another example, ignore all the details here, but the idea is you can ask an LLM, sorry, to show its work. And you can have a separate model rate the intermediate steps. So here you can see those intermediate steps colored, right? The dark green is like, oh, this is not, I'm not sure about this. The red ones are just wrong. And so you can see on the left, the sequence is all bright green. All the answers were scored well. And on the right side, things went wrong. And we're able to figure that out. And based on those ratings, you can figure out whether the final answer is a good choice. The point is, both of these can improve performance by many factors, depending on the task. There's a cool thing called Code Interpreter that can do math and data analysis and visualization, interactive graphing, basic image editing and analysis. So this example, there's a data file like a spreadsheet that's uploaded, and the user asks, hey, can you create a bar chart of the top 10 most frequent artist names? And you can see here are the results, right? It kind of does all that work for you, creates the labels and the axes. And this is a very basic example. There's so much more that it can do that is now being unlocked. It's not available, the code interpreter is not available to everyone yet. But again, the AI Explained channel has a great demo of it. The video is called 12 New Code Interpreter Uses. So if you're curious, you can check it out there. One of the problems that these models have is that there's a long-term memory problem. It can only take in so much input, and it can't remember, right, across different sessions, large amounts of information. So people have worked on that. And there are various workarounds, and sorry about that. The basic idea is that you could come back and it would remember things that you said in the past, right? So in this example, this guy Rick is chatting with the GPT, and the GPT is able to remember that what his favorite city is, for example. Then there's these classes of kind of more autonomous GPTs. So AutoGPT automates the steps needed to complete complex tasks. So the user is able to give just a fairly basic high-level input, and the model figures out all of the rest. It figures out the intermediate steps. So here, the user says, I'd like to order a pizza. And the model is listening, and it understands the audio. And the chatbot says, okay, what type of pizza would you like? The user says, okay, 11-inch pepperoni pizza, regular crust. And the AI does the rest. So here's what's going on behind the scenes. It looks a little complicated, but the idea is you can connect, the thing to take away is that you can connect all of these different apps, and the LLM can figure out how to use them correctly, right? And so, for example, here, there's an app called Bubble that allows people to build custom web apps without coding. It can connect with the other apps. 11labs.io creates realistic text-to-speech. Twilio allows you to make calls and pull audio from a call. And the GPT is able to drive this process autonomously. That's pretty cool. And the next thing is learning agents. So again, you can have, there's an example of this thing called Voyager, which was exploring this gaming world of Minecraft using GPT-4 for planning and developing new skills. So it's able to go do various tasks inside of the game. The key point here is that GPT-4 is used to do the planning, to do the exploring, to do the learning of new skills. And it shows how you can have different types of autonomous agents tuned for specific tasks. And of course, you can mix all of these LLM-specific techniques with traditional programming techniques and data structures. And so this, again, opens up a vast space of interesting possibilities, kind of cool things you can do, but also harms. And you'll find that this is kind of the recurring theme throughout the presentation. Despite all these improvements, LLMs still have what's called hallucinations. So a hallucination happens when an LLM produces text that's factually incorrect. And typically, LLMs do this with a lot of confidence. And that's kind of the joke, right? That it says whatever it says with striking confidence. And when it's right, that's helpful. And when it's wrong, it's a big problem. Um, sorry. So why do these hallucinations happen? There's a few reasons. So one is when it's trained, it actually doesn't know what the actual truth is. It just learns based on the patterns that it sees. And it does that fairly intelligently, but it doesn't always get it right. The data that it trains on could be noisy or inaccurate in one way or another. The models don't actually have larger contextual understanding, right? They don't understand the world fully. They only know what they've learned, which turns out to be a fair amount. But again, there are some important gaps. And these models, because of the way they work, they tend to value fluency and coherence over accuracy sometimes. And so it'll give you a response that reads very well, but is actually just wrong. And to be fair, this has improved a lot from GPT-3 to GPT-4 as an example. But it's very hard to get rid of entirely for many reasons. But a big one is that actually when it generates text, uh, there's a probability for each piece of text that it generates. So it doesn't generate the same results every time. So it's not deterministic. And that's a big problem. Also, one hallucination can lead to more because previous outputs are factored into future outputs. So when it's generating new text, it kind of looks back at what it already said. And if what it already said was wrong, now it can be steered kind of off the path and be very unhelpful. And of course, there are big risks when you put all this together. Big risks because society is in this phase where AI is being integrated as rapidly as we can into everything. And so when we have this hallucination problem, and we actually have models that perform pretty well, then there's a lot of risk because we can start to rely on them more. And then when they fail, there can be catastrophic coordinated failures. And actually, this is something that was mentioned by the head of alignment at OpenAI, that when we scramble to integrate everywhere, we have to pause, realize that the technology is immature, and that this hallucination problem and other problems, we'll talk about those, can all show up in a large scale across our society because we've run ahead and implemented everything. And of course, after this was said, all the plugins for external apps were released. So um, people are really trying to mention the harms, but the race is ongoing. And we'll talk a little bit about the dynamics underlying the race as well. So key takeaways for this section, we're not talking about just ChatGPT or generative AI, but general purpose AI. And here, generative AI is kind of a subset of general purpose AI. I'm using a definition from the European Union. I think it's a good one. This is not yet artificial general intelligence or AGI, but it is improving very, very fast. People define AGI in many different ways, but getting sucked into that debate actually distracts us from dealing with harms from the actually very capable AI that we already have. So these technologies can be used with an infinite set of external tools and programming, and they're improving very quickly, but they still hallucinate confidently and unreliably. And in some cases, right, the performance really is like 10x per year with a combination of software and hardware and new types of training and new types of prompts. All that stuff is driving a lot of improvements. So let's talk a little bit about fear-mongering and hype. So this comes up a lot when we talk about AI. And first of all, understanding the situation accurately is critical. This is kind of the fundamental thing. And what we're talking about is general purpose AI's rapid integration across society, not just generative AI. Because sometimes people forget that and they talk about the chatting thing or the image generation thing. And actually the broader capabilities bring in a lot more risks. We have to understand its capabilities and dangers, right, in order to set the right rules. So does hype help or hurt? It's mixed. Hype definitely helps companies because the tech actually is very powerful and it can do all kinds of fun things, and it's highly marketable. So of course they're building big campaigns. You'll see this in a lot of advertisements these days, right? Every company, every CEO is talking about the benefits and the cool things that can happen and how we can save time and improve productivity and grow the economy. And what happens is when these products get released little by little, and they actually are kind of cool, the public can get enamored with these exciting new tools. And that makes it much harder to get not just regulation, because there will be some kind of regulation, but the question is whether it will be adequate to protect society from the large scale of harms that we're talking about. Tech companies tend to, there's this playbook that happens where they build powerful technology, it gets broadly deployed and adopted. And then there's this like ask for help regulating what have become impossibly hard problems. And we're sort of on the path to doing the same thing with AI. Um, so where does hype kind of help us a little bit? Well, sometimes if we can understand these capabilities well and understand the harms well, the warnings about the dangers can actually help to drive public pressure and get the right protective measures in place. As an example, right, the US government tends to establish tech policy more reactively as opposed to proactively. So you kind of need this large scale public pressure in order to make adequate change. So why fear and danger? I mean, this is kind of similar to climate, right? There is big risk at play, both in the immediate term and in the long term. And we've got technology that has already exceeded the limits of our, sorry, not sure what's wrong with my throat, our physiology, our governance, and our natural ecosystems. And AI has kind of supercharged this whole process. So we need swift action. So why is this race happening? And I think a lot of this comes down to misaligned incentives. So let's talk about that. Misaligned incentives create a downward spiral to misaligned technology. These aren't in any particular order, but they're kind of interesting to look at. So there's systemic accountability, right? We don't want to get fired. We don't want to lose face, money, power, or whatever it is that we might be holding on to. Whoever you put in the CEO spot, regardless of how much you think they're a good person, will have to fight those pressures. There is this kind of accountability, right, to board, shareholders, and the economy that everyone has to deal with. There's the usual suspects of money, power, social status, and recognition. These are pretty common. Sometimes people find themselves with a certain kind of lifestyle, right? This could be money, this could be status that they need to maintain. Competition is a big one. People underestimate the desire to win, the desire to be part of a winning team. And actually, effective CEOs tap into this and they get their teams aligned and executing crisply against a common opponent. And by the way, this race for competition, this competition includes the race to publish research. The thrill of discovery, this is a big one, right? We all experience forms of this in our lives. We might discover a new recipe or a strategy for our favorite sport. And for many technologists and researchers, this is actually the deepest drive. And these are normally people at kind of lower levels, right? But a few years ago, AI pioneer Geoffrey Hinton was asked why he was doing the research despite the risks. And he said, look, I could give you the usual arguments, but the truth is, the prospect of discovery is too sweet. And I think he was just being candid and honest there, but that's just something to keep in mind when we think about how this is all playing out. Cultural conditioning, right? What did you learn from your parents, from your education? What do the people around you talk about? Not being aware of our conditioning creates blind spots. And it's easy to chase some of these kind of false incentives if there's this idea in your subconscious that tells you that when you get this done, finally everything will be good. This is kind of a deep point. But when people have so much power, this kind of self-exploration becomes much more important. In practice, all these incentives align, all of these incentives misalign, and they magnify what's already a rapid amplification and distribution process without sufficient risk assessment. And of course, that's bad for society. So next, I want to quickly talk a little bit about how some aspects of how LLMs work. So first of all, there's this idea of algorithms and transparency. So the traditional thing, when you think about an algorithm, people think of something like this. This is a flowchart where you get some input, there are some decision points, and then you kind of make a decision, right? The algorithm says approve or reject to this person for a loan, for example. And here's a simpler version of that, right? You take an input, make a decision, and give some output, big number or small number. Very simple. You can look at it and you can understand how it works. Now on the right side, we look at a neural network. This is a very simple neural network. Neural networks are modeled on the human brain. And just like our neural pathways get weaker or stronger over time, the connections between these neurons get weaker or stronger as they're trained. So there's different numbers that represent the weights. And then, so once the model is trained, based on the input, different neurons light up right inside of the network based on those weights, and then you end up with a value. So that's the red output at the end. With LLMs, the output is the next piece of text. So that's a very simplified explanation. But the point is that the workings of it are quite complex. So it ends up effectively being a kind of black box. Black box neural networks are used all the time in systems like social media and recommendation systems, but the new forms of general purpose AI are a lot smarter. And this is a simple example. It actually looks more like this, and actually it's more like a million times this. Seeing inside is hard, but we can, so just to give you some intuition for how you could do that, you could visualize, right, how the nodes light up, just like we do fMRIs of brains. You could do techniques like the step-by-step reasoning that I showed a few slides ago. But there's challenges there because sometimes the steps that it reports are actually not accurate. And so we can end up developing false confidence that a model is actually doing what we want when it's not. Next, I want to talk about some ways that recent LLMs encode a sense of meaning or understanding, because people often talk about them like they're just repeating patterns of words without any understanding. So take this example. We've got 5 English words and 3 kind of axes of flavor, right, to these words. So genuine, right, is a positive word. Surreptitious is not so much. Subtlety, surreptitious has a lot of subtlety in it. Enthusiastic kind of doesn't. Intensity. Enthusiastic is a very intense kind of word. So by understanding those kinds of flavors, LLMs can start to group words or concepts with similar characteristics. So here you could look at dimensions like age, size, and energy consumption. So all the animals will be close together. All the villages will be close together. And in reality, it's kind of incomprehensible, right? LLMs have hundreds or thousands of dimensions. And so we can only understand, not 3 dimensions like here. And so we can only understand them using like big tensors and complex mathematics. But you get the idea. Another example, position matters. So in this case, where we put the word only changes the meaning of the sentence quite dramatically, right? So the models factor that in, and they understand that different words at different positions mean different things. They also understand which words in the input are important, and they also look at the relationships between all of the different words as they try to predict what the next piece of text is. So in this example, the words are colored based on importance. So based on the model's training, it knows that although rained, Jojo, decided, and go are probably important words, and the orange words are kind of important, the yellow words are less important, and the gray word, you can probably ignore it. it uses all that information as it makes the prediction of the next piece of text. The next thing is about developing kind of deeper understanding. So in the course of its training, a neural network builds up lots of connections and weights between all of its layers. When we ask questions, different parts of the network light up based on what patterns they've picked up during training. So in this example, right, the early layers might have picked up something about basic sentence structure. The middle layers might understand something about syntax and semantics. The later layers might understand a more holistic kind of structural level. And so again, the details are complicated, but this is a very rough way of explaining how LLMs understand language so well. And again, remember, these networks are massive. So they are able to pick up all sorts of things that humans might have a harder time picking up. The last piece is that there's an important piece in the training process, models like ChatGPT, they do a step called reinforcement learning with human feedback. So in this step, humans help the model to make sure that its reward model is actually rewarding the right behaviors. And that helps to produce more nuanced responses, better alignment with human values, because the human feedback, right, can kind of interject some of those values. Adaptation to new scenarios that didn't show up in the training data. Error correction, so fixing problems that may have shown up in the training kind of erroneously. But because humans are involved, just like with the rest of the training, right, this is another opportunity to introduce bias, ambiguity, you can get over-optimized, etc. But just want to mention this step because I think it's very important. So, key takeaways, LLMs operate with a lot of opacity. They have much more understanding than just repeating word sequences from their training. So now, okay, so far there's a lot of things about kind of how powerful the models are, but actually there's a lot of things that are also going wrong. So let's talk about that. Here are some of the current, just recent harms, right, over the last months. And you can see across many different domains, right, really dangerous things that have been happening. Here's some more. And just recently, right, there was the fake Putin example where there was a fake media and a cyber attack as well. So that you can see how these combinations can be quite dangerous. This is a chatbot explaining how to make napalm after the user figured out how to kind of jailbreak it, right, to kind of break it out of its restrictions. Here's an example where an AI chatbot is now integrated, right, into Snapchat. And it's always there, right, even though your friends might not be. And here's an earlier example where this kind of chatbot was helping a 13-year-old plan a romantic experience with someone who was 18 years older. And so this has all been rolled out, right? There's 375 million users. Snapchat has fixed this particular example, but the point is, these kinds of examples will always come up. This is very immature technology. But yet we're shipping this technology widely. It's kind of crazy. There's another military example if you want to look it up, but this is sort of like, in summary, it's like playing a computer game, and you're able to make requests and give orders and sort of plan how you're going to execute in conjunction with the intelligence of a chatbot. This demo is kind of incredible, right? But it also gives you an example of this is just the tip of the iceberg. There's so much more that's happening that is classified. And then there's robotics. So here's an example from a year ago. So you get the idea, right? The point is we are hooking these up to increasingly more powerful AI. And are we going to be surprised when bad outcomes happen? I think that's just, it goes from science fiction to like real possibility. A different manufacturer called Ghost Robotics teamed up with Sword International to produce this robot dog with a custom gun in 2021. So again, right, there's this kind of rush to integrate everywhere. And just want to paint these realities. There's a conversation of net good versus net bad, right? There's incredible potential. Um, Obviously, we're going to have the ability to have new drugs, new material science, new energy, new climate solutions. And this is all could be very exciting and very good for us. But if we are reckless with the deployment of AI, and we have AI that floods democracies with synthetic media, accelerates the development of cyber weapons, and disables actually critical infrastructure, and then we decentralize, right, advanced AI to extreme actors, there's a lot of possibility for things to go wrong. And we won't get to all the good things because we'll get stuck. We won't be able to get through the door. And also, right, all of our societal kind of structures, right, law, religion, culture, relationships, all of these are built on language. And we've now given out the keys, right, to that manipulation. Another note that's important is there's a lot of nuance to this, but with open source, traditionally, again, there's a lot of value in open sourcing kind of procedural algorithms where we could see inside, see the flowchart. But when it comes to neural networks, open sourcing is a lot, it doesn't mean as much, right? It's sort of like you don't get the weights, you get the source code, you get sort of the training process, but you don't get the weights. The weights are sort of where the magic is. And so there's some risk. People have also gotten weights, and when those weights are decentralized, people can actually reproduce the functionality of the original model. There are also a lot of new models that are able to run on simpler, commodity hardware and run very well. So we need to find novel solutions to bind power and responsibility. Again, we see the pattern. We've seen the same pattern with social media companies where the investments in safety are very small compared to the investments in innovation. It's not that they're not happening. They're just woefully inadequate for the scale of what we're releasing into society. So then there's this topic of extreme risks. And I know there are many people who feel like this kind of discussion of extreme risks detracts from real world harms that are unfolding right now. And that's true in many cases, like that does happen. It's also true that in many cases, the people who emphasize extreme risks and are really concerned about it, they tend to have quite good lives. And so for them, these extreme risks are the ones that would really upend their lives. And it would take them to a situation where they don't feel safe or they don't have reliable income. So there's this language, oh, we're all in the same boat. But actually, not everyone is equal in that boat, right? Many people on that boat already feel unsafe and don't have reliable income. And they'll also face those more distant risks. So there's this reality, right, where a lot of resources get allocated differently based on these differences. And real world immediate harms often get less attention, partly because they're sort of less glamorous, right? They don't get the headlines as much. And partly because they're really hard. They involve deep societal problems that are difficult to address. So we're going to talk about both today. And one of the things I wanted to show, people often ask about, they can't visualize this pathway to extreme risk. And so this table shows a bunch of different examples. I won't go into them all, but you can see many of them are already possible now, kind of deception, persuasion, political strategies. And as we hook these technologies up to more and more of society, there is going to be more and more obvious exposure. And we need to be really thoughtful about that. And if the technology is taken over by a malicious actor or the technology itself makes a bad decision, we've opened the door to very large consequences. So all this is driven by what we call multipolar tribes, right? These are competitive environments where everyone's engaging in harmful behavior, not because they want to, but because they'll lose if they don't. So AI companies will lose if they don't rush innovations out to market. Someone else will take their market share. So this is kind of one of the challenges. This is a complex topic. I just want to put this slide up for those who want to pause the video and look later. There are ways to get out of it, and so there's forms of this that we need to do and are in progress as well. So key takeaways: order matters. We can't get to the good stuff if we let society break down. AI demands novel ways to bind power and responsibility. And we have to attend to both today's harms and future harms. And we can't just forget one or the other. So what about the economy, right? How does this all play out? Most of the world uses a mixture of capitalism combined with sets of rules to make sure that it's playing, somewhat fairly. Capitalism has done a lot of good things, right? It's given us longer, healthier lifespans, give us access to food, clothing, shelter, information, intelligence, this kind of virtual intelligence, connection. And there are some other things about it, like it's less sensitive to who's in power because it's like a machine that just runs itself. So whether you like the person who's president right now, the machine still kind of runs. It leads to rapid process. It leads to rapid progress. And that's driven by a conversion of resources, right? Natural resources or our minds or labor into consumer goods and services. So inherently, it's about extracting value, right, from those resources and reallocating that value. But the problem is, obviously, it only benefits people it tends to benefit people more who have more resources to start with. And so in this process of extraction, we've exceeded many of our boundaries, right? Nature, our health, our minds, and even the functioning of democracy. And technology accelerates this process. AI is now the greatest accelerator we've ever built. But what ideas are we actually accelerating? Here are some of those ideas. These ideas like growth is good. One can own land. Nature is here to be converted for human purposes. And sometimes even other people, right, are grouped into that, right? This idea that there are a stock of resources to be converted for one's purposes. These are kind of terrible things that we've done in history and still continue to happen in parts of the world. And people are perfectly rational, right? And of course they're not. But these ideas, they're not just ideas, they become cultural assumptions, and then they become baked into our institutions, our policies, our laws, and actually into the prevailing mindsets that drive behavior and drive technology. And so you can see this kind of extractive paradigm. You may have seen this. We like to show this a lot. These kinds of assumptions appear in many domains of technology, and they apply to AI, and VR, and Web3, social media, wherever. Anyone who's trying to grow things quickly tends to have this set of mindsets. So what happens, right, in the economy when companies get good at something and it's useful in a small dose, so say like a shoe or a drug or a social connection or some kind of nice drink, when we tie that production and growth to metrics and then we try to do the infinite growth thing, it's easy to lose track of our values. And so what's going to happen with AI? The vast majority of companies are going to look at how AI can accelerate their existing operating models and investments. So that's going to bring an incredible reduction in friction for consumption, which also means an incredible increase in harms and extraction. So we've got to be really careful here. Another concept here is when we turn a tree into lumber, we give up, right? The way the leaves produce oxygen, the way that the roots, right, protect from erosion, the way it provides a habitat for animals or food for animals, right? All these things. We do the same thing with children, and we give up, right, sleep, we give up relationships with family and friends, all and learning, all because kids get stuck on devices. All of this comes at a cost, right? Billions of air conditioners. So we've got 2 billion air conditioners, 1.4 billion cars, 1.5 billion cows. And when you put that all together with all the other things that we're doing, it adds up, right? All the emissions add up, and it leads to much more energy being stored in the atmosphere. And as a result, we end up with 19 of the last 20 years are the hottest on record. We've got fires, droughts, hurricanes that destroy homes and displace people globally. And of course, so this goes up exponentially, and the harms are unequally distributed. So of course, the poorer people end up shouldering more of the harms that come from all of this whole process. And so it's like we're in a car and we're accelerating off a cliff, and AI is going to accelerate this car even faster. And sometimes people forget that we're all in the car, right? Even the wealthiest and most powerful people are in the car. And so we have to find responses that are actually adequate, not just letting off the accelerator, like donating 1% of profits, which actually just still driving off the cliff. How do we turn the wheel? So that involves changing our economic incentives, leveraging our finding ways to change our mental operating system and the unsustainable ideas that so many minds are living by. So business as usual, and certainly not AI accelerated business as usual, isn't going to work. So there's a useful equation here. This is just kind of an approximation, but I think it helps conceptually. Competition and extraction, right? When we exponentiate them with technology, we end up with existential risk, right? This is a situation where the rules of the game, like our regulations, can't keep up with what we're building. And so we end up destroying the ecological, physical, and mental foundations that humanity relies on. And, when you take this to an extreme extent, that's when you get this existential problem. We can just use the word catastrophic if you prefer, but this is kind of the model, a useful mental model. So, because price is always at the center, and it magically folds in supply, demand, costs, and all of these things, it has some benefits. But as we saw earlier with the example of the tree and the lumber, price leaves out many aspects of what makes nature and people really special. And it's very dangerous. But so what happens is if we want to make a difference, we need to affect price. And again, I'll leave this up. This is something that as a field, as a group, right, we have to do effectively, right? We have to have an agenda that we use to drive external pressure. So these are penalties to price, right? Through media, through policy, law, education. But we can also inspire better behavior, right? We can kind of subsidize a move in the right direction through product and culture change, through training, through mobilization, movement building, all of these things. And when we think about aligning our institutions with our technology, we have to remember there are two key faculties that we can't lose sight of: sense-making and choice-making. But what happens is increasingly these are mediated and often corrupted by our technology, which is driven by perverse incentives. And that has horrible consequences. So the complexity of the issues we're facing is going up rapidly. But actually, our own technology is making it harder for us to make sense of this complexity. And so there's a wisdom gap. And this is kind of the challenge for all of us to kind of help to solve. And there's a lot of work being done in this realm of public interest technology, as it's called. So I've put some links here. There's a Public Interest Technology University Network. There's the Council on Technology and Social Cohesion that we're part of. The Civic Tech Field Guide. So all of these are things you can check out. There are alternatives to GDP. GDP was not invented to do all the things that it's being asked to do now. So there are other ways to do this. So I've listed some of them here. There's also work on alternative economic models by folks like Donut Economics, the New Economy Coalition, Sacred Economics, the Work That Reconnects, Circle Economy. I'll add a slide on this later. But this is a time to really look at these alternatives because we are going to need them. So key takeaways, right? This kind of equation, helpful to remember. A price-centered economic system is really only sensitive to price. So we've got to figure out interventions that connect to price. And AI demands, it's an opportunity, but also it's something we're gonna have to do. These are conversations that people have been having for a long time with COVID, with climate, with inequity. And this is a time when we've got to jump ahead to do this. Next is the topic of deepening disparity, right? Leaving behind people who have less and who aren't kind of the common case in society. So let's talk about jobs. This comes up a lot, right? So massive job losses are likely, right? In the short term, huge productivity gains will happen for anyone who's using AI. And this is the thing, everyone's going to kind of get drawn into integrating these technologies. Soon after that, we'll have lots of layoffs, right? Because we'll get good at using AI and there'll be more impact on cognitively intensive jobs. And that correlates with higher education levels. Um, I'll explain a little more about the layoffs in a moment as well, just in case that jump wasn't clear. Um, and this is a big psychological and status hit, right? For people who are used to like thinking jobs and being in this kind of certain portion of society, that would be hard. There's a less immediate impact on physically intensive jobs, but also keep in mind that robots are being trained and are increasingly capable. So in the end, there will be fewer jobs, more labor competition, and lower wages for everyone who's left. On the bright side, since there is only this kind of bright side, I guess, is the cost of producing goods and services will drop. But of course, that's because less humans are involved. So when you hear that AI can partly help you with your job, that actually will translate to lost jobs. And Sam Altman explained this well in one of the talks. There's a huge premium on coordination, on health benefits, all of the things that we do to take care of people. If you can make one person twice as productive, that replaces not two people, but more like 3 or 4. And so when you hear this question, this kind of statement, oh, AI will create new jobs, that's kind of the wrong point, right? The question is, how many more jobs will be lost than gained? What's the net? And what's going to happen to all the people who are left out? And the answer is not retraining. Retraining addresses only a very small percentage of that group. And also now there's no new frontier to grow into that's kind of obvious. Like in the past, there was knowledge work, cognitive work, right, that we could grow into as we got more industrialized. But this time, it's not clear what that would be. And I haven't heard any good answers for that yet. I'm going to skip through this because there's a lot of detail here, but again, anyone who's interested can pause. The bottom line is there was some analysis done by OpenAI on jobs. And basically, there is a vast number of jobs with a large exposure and a large amount of potential income at risk. And that's kind of the bottom line. And so now let's talk about some of these immediate harms that we're talking that come up. So let's say we have a sophisticated AI model that analyzes this guy, right, Michael, and tells us if he's eligible for health coverage or a home loan or disability insurance. This can go wrong in many ways, right? First of all, the model may not work well, just may not be a good model for him. The AI could hallucinate, as we know. Most commonly, the problem would be that the model will try to fit Michael's characteristics to past data that it was trained on. So any negative or positive factors that are encoded in that past data will influence the result for Michael, which ends up pushing Michael's future in the direction of that past data, right? And so, for example, to make it concrete, if Michael's kind of characteristics match in terms of race or zip code or education with people who had high health premiums, he's likely to get a high health premium too, even though he might have very different circumstances that the model doesn't understand. So that's one aspect. There's another aspect, which is, so let's look at another example, right? Where we're using, again, AI to model health insurance premiums. This map shows the correlation between COVID cases per capita. So those are the blue circles, right? Bigger circle means more cases per capita. And pollution, which goes from green to red in the LA area. So the model could learn to predict that people living in highly polluted areas get sick more often, and therefore they should pay higher insurance premiums. So this is how a smarter AI could actually lead people to unfairly bearing a burden for societal problems like pollution that they can't control. So there's this trap, right? This is a great example of how getting better and better actually causes a different kind of values problem across society. And again, affects people. There's a very large correlation between people who are poorer or marginalized in other ways and these kinds of very sophisticated narrowing effects. And of course, all the other things that happen with social media, the kinds of harms that have been happening, will continue to happen. I just wanted to give these two examples. And then one last thing about how AI accelerates social defaults and kind of conditioning. So when AI is widely integrated across society, it conditions all of our minds, right? Because we end up interacting with it all the time, and that has an effect. So lots of defaults and stereotypes are actually baked into the training process or baked into the AI. Sometimes that happens in obvious ways. And these are the things that people often talk about, like gender, race, economic status, age. These are kind of more obvious. But a lot is more subtle. And so an example would be like accent. Certain accents are perceived as smarter than others. Or marital status, right? Where marriage would be deemed as good or stable. And the model will learn all of this stuff. Another example could be how leaders behave, how they speak, right? The structure of their sentences, the gender of leaders, who drives the narrative in movies, right? Certain types of characters with certain types of characteristics. And so the AI learns those patterns, but when people interact with it, people start to learn those patterns as well. This is not about hallucinations, right? This is about encoding social structures, so social defaults and stereotypes into the data. There's a great discussion of this, as well as a lot about solutions in a paper called On the Dangers of Stochastic Parrots. So I'd encourage you to check that out. Just note that the paper was written before the release of GPT-4. So some of the model capabilities have grown since then. But this aspect is covered really, really well. And the growth in AI capabilities is a problem that every paper has. And every talk is going to have as well. So recap, big job losses likely, more for higher education levels, big wealth inequality. AI reinforces past patterns and can over-tailor risk assessments, and it strengthens societal defaults and stereotypes. So we end up with this kind of catastrophic mix of conditions. I want to recap. We've got frenetic innovation, where companies are seeing the opportunity of a lifetime. We have synthetic media, where we can't make sense of the world well. Reputation and trusted relationships will become extremely valuable in that world. We have distributed access. Every scam requires less time and becomes more profitable. Malicious actions become easier to do. We can't even keep spam calls and texts from our phones. So just keep that in mind as we think about the explosion of possibilities that we are now allowing. And rising inequity. Inequity itself is a catastrophic risk because it breaks the functioning of economic systems and democracy and introduces harmful threats, affects mental health. There's all kinds of problems. The last thing I want to talk about is when we have this kind of innovation, we also need clarity. And we need clarity on why we're doing it in the first place, what our definitions are of kind of thriving and happiness, what problem are we really solving? And I think conversations around alignment have to include better access to food, clothing, shelter, medicine, mental health, and the reasons why solving those problems aren't well incentivized. We don't want to just be hamsters, on the wheel of life, bouncing between wanting what we don't have and disliking what we do have and never being content. And this is a lot of what the economy does to us. There's many aspects of thriving that we need to understand. So a balanced relationship to pleasure, pain, and meaning, gratitude, creativity, learning, balance, and respecting the flows of life, acceptance of challenges that come our way, care and kindness. This doesn't come up that much in the conversations around technology, and it really needs to. Quality relationships, reducing regret. Um, I highly recommend the Thriving and Centering Values modules of our course. It's a free course, Foundations of Humane Technology. And that content will help you with all types of technology, including AI and social media. So consider checking it out and signing up. But if you want, just watch the videos, which are just on the website. You can just click into them. A human rights lens is also important, right? Looking at the basic capabilities that humans ought to be able to have. We can't lose sight of that in the conversations, especially when we talk about AI alignment. This has to be a critical part of the conversation, as well as who is at the table for those conversations. And again, the fairness and justice module of our course has a lot more about this. There is a risk where we end up in a world where artificial pet rights become more important than real human rights. That sounds like a joke, but it can really happen. And again, that's because people with fewer resources aren't served well in capital-centric economies. And as we've seen, that's going to become an increasingly larger number of people. The last thing I want to touch on is AI and kids, because there are a lot of questions about this. Relationships are the entry point. So social media, phones, toys, media, games, all of these are going to be supercharged with AI, right? Because AI is going to allow much deeper relationships to be built in terms of interactions, especially listening and reacting and kind of generating interactive, like interesting text. And in many of these domains, AI is just going to be a tool that's going to increase harms and create huge opportunities to hook kids and create big dollar opportunities. I think that's a fairly obvious thing that's going to happen. There are some good things that could happen. So mental health support could become much more accessible. But there's a risk of AI chatbots being tied to the wrong places, right? So if the chatbots live on social media, that could be really dangerous because they have perverse incentives. And again, I want to get, there's no substitute for like talking to a real human therapist, but the model that we have of very expensive therapy and doing that like what, once a month or like once a week at huge cost, it's not accessible for a very large number of people. And so the people who figure out how to get these kinds of models implemented well, there might actually be something valuable there. Again, big asterisks, right? But just trying to name some of where there is hope. In education, there's broad opportunities to be helpful. The way that kids can learn can be much more interactive, and learning is going to be much better that way. And the other interesting thing is, like, so I'm from Sri Lanka, and you could have kids in Sri Lanka having access to some of the same stuff, like through ChatGPT, right? Which is kind of interesting. And again, there will be always like new levels of inequity where schools that are better resourced will do this in more sophisticated ways. But overall, there is some possibility that there could be some narrowing of the gap. And so, for example, kids who have parents who can't attend to them as much because maybe they're working 2 jobs or 3 jobs, like the opportunity to learn with a partner that's interactive and knows all the material quite well could be profound. Um, I've seen some demos of Khan Academy trying to do this kind of thing well. So again, big asterisks because it all remains to be seen, but there are some opportunities. Lastly, there's this point on resilience. I think it's dangerous for kids to become accustomed to getting only what they want, only the experiences that they want, avatars that look great and sound great and always support them and everything is positive and easy. This is a challenge for adults as well. And so there's this challenge where instant gratification at an all-time high means that resilience is at an all-time low. So we've got to be really, really careful about all this. Much more that could be said, but I just wanted to touch on that. So just a quick recap of solutions, and people always want to kind of remember that within the existing system, interventions have to affect price. Remember that kind of rainbow colored diagram, right? You have to mix all of these different pressures and incentives to get things to change. We are going to need global coordination, and we need safety investments commensurate to the investments in growth. We're going to need heavy input from social sciences and wisdom traditions to figure out the values problem, right? Well, how can we align on values? We have to figure out how to center human rights and growing disparity all the time. That can't be something that's thrown aside or said that it'll just be benefits will trickle down, because they really don't. They don't trickle down well. We need to center values explicitly, and we need to figure out how to transition to new systems. So how can you help? One is learn more about AI, watch this talk again, watch the AI dilemma again if you haven't, take our course. Here's a good ML safety course, machine learning safety course, if you are kind of interested in more advanced stuff. Our friends at All Tech is Human have a great reading list that you could check out. Speak up where you have the opportunity, but do it in a nuanced way. Represent multiple sides of the argument, and that's what we've tried to do here. Weigh in on forums and discussions. Speak up where you have agency. There's lots more we can say, but that is all we have time for today. Thank you so much for your time and attention. And now we're going to do breakout groups. So Andrew is going to put some instructions in the chat for how you can join different breakout groups where you can kind of discuss with other people kind of your impressions and your questions and all that stuff. So yeah, and we'll try to do more of these maybe. Let us know. Thank you again. Take care. Bye for now.